guys, so today we're looking for long-toed salamanders in the restoration site from Green River College. And actually, they must have just started laying them because there's a ton of egg masses here that weren't here a few weeks ago. And we found a little lady or guy, I don't really know, but look at the cuteness. I'm not gonna touch it simply because my hands have toxins on them that can hurt their skin. So if you ever see these guys or frogs, please don't pick them up without wearing gloves because you can harm them. Their skin is really, it's kind of fragile in that way. But, so this is a long-toed salamander, and you can tell by, it's a little bit smaller than some of the other salamanders that we have here. And then it has this, you can see this yellow stripe that goes down its back right here. The only other real salamander that you would see that you might confuse this with would be the Northwest salamander, and it doesn't have a stripe, the yellow stripe down its back. Also, if you look right here at its back foot, you can see that super long toe that it has. I guess you would consider that its ring toe? I don't know. Anyway, that's where it gets its name from the long-toed salamander. So we're just gonna make sure that we cover this little gal right back up because we don't want it to dry out. He obviously chose this spot for a reason. And there we go. Flip the rock back over just to make sure we didn't squish it. Hope I didn't squish it. I tried really hard to not. So then I haven't checked over here yet to see if there are any eggs in this section. There's definitely a lot of places that they can attach their egg masses to, which is kind of important when you're looking at when you're out looking for these guys. There's a few things that you want to look for to help you. I mean, obviously you're not going to look in a spot where you're not going to find any. That's kind of a waste of your time. So what do you want to look for? You want nice still water. So this right here, this is probably moving a little too fast for them. It's going to agitate them, so they probably aren't going to come over to this spot. But this water here is nice and still. They like ponds, puddles even. The water quality doesn't have to be super great. Obviously you don't want your little babies, once they emerge from their eggs, to be suffocating in oil and pollution, but I'm sure it happens all the time just because of urbanization, which is one of the key reasons why we are losing this type of salamander is due to urbanization, since they like these still pools and water, and you can find them a lot in wetlands. And we're taking out wetlands all the time. So save the wetlands, guys. They may not be beautiful to you, but it's beautiful to something, and they're extremely important. So we have right here, we have nice still water, and then you want to make sure that there's like sticks, or you can look in here, there's debris all in the water there. That's so they can attach their egg masses to it, so when we have heavy water flows like we have a lot in Washington, those eggs just don't get ripped right on down through and destroyed. So let's see if we can find one. You also want to make sure that it's an area that has macroinvertebrates in it. They do need a food source for once they emerge out of their little gelatinous state. And so I've been working here for over a year, so I know this area pretty well. And there's a ton of macroinvertebrates in here. There's some scuttlebugs, there's larvae from different flying insects. You can see all that oil, it's kind of gross. Also, I don't see any eggs in this area, so I'm assuming it's because of the oil. So we're not going to spend too much time here, but it is interesting just to note if there were any or not. So scuttlebugs, there's different insect larvae, there's leeches, which are disgusting, but they're here. Kind of makes me a little apprehensive to just throw my hand in there. So they definitely have a ton of things to eat. There's also a bunch of aquatic worms, there's more oil, that they can munch onto once they get bigger. And so these guys, they're aquatic only in their first life stages. Once they emerge out of their gelatinous state, they'll have little floofies on their head, and then they'll start to grow their legs, much like a frog would in a tadpole stage. And then once they're ready, they will emerge from the water and they do become terrestrial salamanders, meaning that the only other time they're going to come back to the water is going to be when they're mating to breed, and that's it. And a female salamander can lay multiple eggs, so it's really hard to tell how many are actually in this area by counting eggs, because she can lay a ton of them. They're not like salmon where they only lay 1 or 2 nests and that's it, and then they die. They can lay multiples on top of multiples. So really you're just looking for how many egg masses are present, are they healthy, and then just keep coming back every year and counting and seeing if the egg masses stay stable, if they increase, if they decrease, and that's going to tell you if your site is good or not. So here is one little lonely egg. You can see the white color right there. So let's see. Woo, that guy right there. So that egg has died. It has deceased. It is no more. It's not a viable egg, and that can happen for many reasons. A lot of factors can come into play. It could have just not been fertilized. It could have had some sort of shock to it. I mean, only the egg knows why. And then you come here, and so these are healthy eggs. And this is kind of typical of what this particular salamander is gonna do. It makes either little singlets, like this one right here, and it'll be like, that guy would be like 1, and then 2, and then 3, like peas in a pod. Or they can also kind of group them up together, and I'll show you one of those here in a second. But also, if you, let's see if we can zoom in enough. Yeah, so the bottom right one, you can see it if you look hard enough. Along the embryo, there is a double membrane that encloses it, and that's really typical of these long-toed salamanders, as in, like, they all do that. I guess typical was the wrong word to use there, but that's how you can tell them apart from the Pacific tree frogs. So their eggs look very similar, but they don't have that double membrane. And they do inhabit the same areas, and they do lay egg masses around the same time. So it is important to be able to know what you're looking at. So we'll just zoom out of there. And it's also interesting to note that this is in the direct sunlight. So there's no, you can kind of look around, there's no actual shade for these guys. I thought that they needed shade when I first started doing this project, but I learned later on that they do not care about the shade. You know, obviously later on in life, they're going to retreat into the forest, and they're mole salamanders, so they'll live most of their life underground in the forest floor. So you'll probably never ever actually see one in adult form unless you walk through the forest, you're flipping over rocks and logs, and like that's your sole intention of where you're at, is to find these guys. But otherwise, when you're out hiking, there's a very slim chance that you'll ever actually see one. And so this is our restoration site. The goal of this site was to get rid of the huge thicket of blackberry that was here. And then these channels already existed. We just improved upon them to try to make the water more still and more accessible to these animals. So when you think about blackberry, it's super thick, the roots go really deep, and it creates kind of a holding pattern. So when you take out that structure, now you've just opened up a freeway for the water to just rush through. So we had to do something about that, which is really important in restoration. Is you do have to think ahead of time. Like, if I take out what's already here, what can I replace it with, or how can I get around the problems that are going to arise, even if you're trying to do something good. So that was the whole purpose here. That's what you see. This is all local wood we just collected from this forested area. There's more of it. There's a lot of downed trees. A lot of these trees are sick, and I'm guessing, so you can see the cedar right here. It's dead. It will fall down eventually, or we can take it down. The pollution is pretty heavy. If you look this way, both of these culverts here, so this one comes from the road, that's all road runoff, and then this one comes from underneath the road, the wetland across the street that has zero maintenance done to it. So we have no idea what that even looks like, but the water quality is just not that great. So it's really difficult for sensitive trees that maybe used to were used to thriving out here, and now, you know, it's slowly killing them. After we were done ripping out the blackberry, we had an excavator guy come in, and he dug up all of the soil and kind of tilled it for us, trying to get whatever might remain of blackberry roots. And so far, it's been about 6-7 months. We haven't seen any reoccurrence of blackberry in the areas that we dug up. We did replant a bunch of things. We have some red osier dogwood. We have some Oregon grape. We planted this poor little cedar tree that's probably not going to make it. And then there's a little spruce tree over there, Sitka spruce. It's definitely perked up since we put it in. I'm not entirely sure if it's also going to make it or not. We also planted some more salmonberry. There was a ton of salmonberry already in here, but because it was mixed in with blackberry, and the only way to really get rid of blackberry is to just go at it, we also had to kill all the salmonberry already present. But it grows back super fast, so it really wasn't that big of an issue. We also took out, this was full of canary reed grass, which is extremely invasive and just takes over the waterway. It's insane. So you can see some right here. So that's canary reed grass. Really difficult to get rid of. Just such a pain to even try to get rid of it. A lot of physical labor. I'd say more than blackberry probably, mainly because it's in the water, and well, that's a whole nother element you have to deal with. So then once we got rid of all the canary reed grass, except for that, I guess we have to come back for that, we planted this native sedge grass right here. And what I'm really excited about is these long-toed salamanders are actually using this sedge, which is amazing. I'm so happy about that. So when we look through here, I don't know if you can see them, but there are some egg masses. So there's a clump right somewhere. Where's crap? It's right there. It's as good as it's gonna get. I'm sorry guys, but that's an egg mass right there. It's a little dirty. So everywhere that there are long-toed salamander eggs in this little strip, they're all on these sedge grasses and nowhere else. And I think that's pretty cool. That means that we did something right. Like we were replacing something that we took out that they can actually still use. So here's another good example of, this one's really super clear so you can see it. And these guys are still in their beginning stages. They haven't gone into their bean form yet, which they just kind of look like a bean. And then once they reach that form, then they're gonna start, then they will start growing their little floofies. So that's their gills. That makes it so that they can breathe underwater. They can still breathe air as well. But they're developing underwater. And then they'll have these like little bumps on their body, which if you've ever seen tadpoles for frogs, like you are probably familiar with that idea. And then they'll start growing out their legs, and then they're in this weird transition state where they're still swimming around, they're eating and all that kind of stuff. And then once they're big enough and they feel ready, then they'll emerge onto land. There are a couple of salamander species that don't become terrestrial, or they have the tendency to not. There is one here in Washington. It's called the Cope's giant salamander. I actually just learned about this one today. I want to do a lot more research and try to find this guy. But the salamander, it's super cool. It's not huge, but it's 8 inches long or whatever. But they're mostly aquatic, so they'll keep their gills and they'll stay in the water the majority of their life. Some of them can morph out into terrestrial salamanders, but it's not that common. So you'll find those ones, I think that they like more moving water, like rivers, streams, that kind of thing. Again, I don't know that much about them. I'm hoping to be able to, in a few weeks, go look for some. But yeah, so that's everything you wanted to know about a long-toed salamander.